Hey, Elon.
Hey Dan.
Hey.
Yeah. Okay.
So, I don't know if Anisha or Alexia are joining. Um, I didn't have much to talk about today. I'm still preparing the next version of the base series. The we did get I did get axe from Bjorn on that, so I think we're in good shape there. But um, Anish wants your patch in there. So your TSM bind patch. I also want to take a look at the lock and accept interface that Anish put in his series, and either and fold that in. So um, I think what I'm gonna do is finish cleaning it up, just and send out just the revisions against V4, and then follow on with another set that adds the guest side. But I think Jason and other people want to see more of the guest side. So that's next for me. I'm hoping that's. I was hoping it's this week. So yeah, maybe tomorrow or early next week. Um,
Uh. Okay. Let me see. I don't see Anish published some TSM guest patch.
didn't he put it?
Oh,
Doesn't he
did
have the lock in it in his series?
oh you mean he in his CCA patch
Yeah.
set?
Hmm.
Okay. I see it. Um. It yeah, I see that. Um. So I'm not sure. Do we want to do something on that for now before we finish the link part?
No. I want to finish the link part, but I think so. Send out the link part, but then yeah, immediately follow it up with the guest side. But yeah, I think.
Okay.
But
Okay.
in terms of getting stuff into the staging tree, I want to focus on getting the link stuff into the staging
Uh,
tree first.
when you say guest side, you mean the TDI bind unbind part and the guest TSM part, is it?
Yeah.
Okay. So so mm, will you uh, create these patches, or you want me to uh, refactor that part?
No, I can take those. Actually, I wonder if do you want to? Oh, there's Alexi. Yeah, I was gonna say yeah, no, yeah, I could no, I'll take those
Sorry, I'm late.
and hey, no worries. And get, we're just talking about um, ordering events. What we're going to do next. I was going to just take that V4 and just spin a V5, which with just the review comments that have come in. But there hasn't been major major concerns there, and niche built on it. So I think we're good there. That was that's what I told Bjorn. Like, hey Bjorn, I think we're coming to some consensus here. And so he jumped in and did his review too. So I think we're okay. And
But when are you planning on pushing V5?
uh, uh, hopefully tomorrow. Um, uh,
Oh,
if yeah, that's because the reviews have kind of slowed down, um, but yeah, that's the plan.
see, this week I was fighting our new box. Last week I was in India. some internal conference thing, so I didn't have really much time to review this stuff.
Okay.
Now I'm kind of finished with this urgent stuff.
Okay.
I actually want to review your patches now and Anich's. So if you push V5, then I wait till V5, or I can comment on V4.
Yeah, I mean, you can. I mean, yeah, I'll push out tomorrow. I think you can wait. You can wait till V5. If you need to do V6, that's fine too. Like we have time. There's no rush. I will say that I think if you did it, if you started on V4 right now, you're not. It's not going to be totally invalidated by V5, but yeah, you can wait till tomorrow. It's no big deal.
Okay then.
Yeah, but yeah. So, but you, Luna, and I were talking about like, hey, like we've done all this work on kind of the host side. Let's see if we can just get that settled, and then go to the guest side. I want to pick up on that conversation we were having about bus master enable and memory space enable and that stuff on the guest side. I like Jason's idea. Okay, go ahead.
What is Jason's idea?
Oh, Jason's idea is about virtualizing bus master enable and not having to deal with it in the core on the guest PCI core on the guest side.
So that right. So far with this bus master enable thing, attestation, what I do now, right, I have this device and I don't probe the driver for it in the guest. First, I do the attestation. I go to SysFS, read all these blobs, say, okay, it's good. Then I have a hook, which you call connect in the guest, which is accept, really. That will move TDI to run state, and then you probe a module, and that thing will just, if it enables BME, enabling is allowed.
Enabling is allowed.
It's disabling, which is not allowed. And there are two cases when we touch BME in the guest kernel, but both these cases can be disabled for our case. Because one is testing int X, which is non-existent on VFs, and the other one is some atomic 64-bit config space update missing, something like this. We can disable both of these, and we don't have to deal with BME or MSC after that.
Okay, yeah, because maybe I misremembered, but I thought you said there maybe some device that didn't like being, if we did a read modify write, even though BME was already cleared and you keep it cleared, if you write 0 again, it would cause a problem. But I think it'd be great if we just don't need to worry about touching BME at all.
No, the device got fixed since then.
Oh, perfect.
I was told that when I was in India. So.
Okay, perfect. So yeah, let's try to keep it that way and have Linux not have to worry about.
But I do attestation before driver probes the device. So that's the key point. If driver is up and running and we need to switch from untrusted to trusted, then we need to invent some hook in PCI driver and hook it up to SysFS and all that stuff.
No, I think Anish has it that way too, and I think it's fine to do attestation before the driver loads. But this is also what I was saying on the on my reply to you earlier. Is also that I think we can push the attestation piece to the back of the to the back of the queue that we have, that we can get the, because
I agree with that, but now I have these people who are trying to do driver thing, right? They don't really care about TSM. Basically, people developing devices, and they really want to do attestation like right now because that's all they have to do in regard to TSM, right? So they're pushing me to decide now on the interface. So I have it anyway, and you have it anyway, right? So it's not that far away.
It's not that far away, but my worry is that, like, we had this SysFS proposal from Lucas, and then we went to plumbers, and then a whole bunch of people had a whole bunch of opinions. And I mean, so I think we can definitely put a interface in the staging tree, but I feel like I just worry that the community is going to have a whole bunch of asks in the interface, like, oh, I want that link, I want SysFS. Like, I don't really care, but we need to, but we just need to pick something and get it past a bunch of people. And I feel like that's a fight independent of.
Right. I suggest we don't push it out like right now, but we discuss it during this call.
Okay. But in terms of like the pressure you're getting, it's okay it's okay if whatever attestation you have, any attestation we have in the tree right now, we tell people like this may not be what goes upstream, but this is what's in the staging tree. Is that
right?
Okay.
And if you push some proposal for TSM and you add these attribute groups as a parameter to something, then there must be some example which is actually using them. And if there is no such example right now, then just ditch them and we'll add them later when we need them.
Yeah, that's true. We could ditch them if there's no consumer yet. Like if, I mean, the thought was that if we do SysFS and you have the SEV version, we have the TDX version, like it would be it'd be the same attribute name, but you would basically register a different handler for that attribute, and that's why I have the groups as a parameter. But yeah, I guess until we have an actual consumer of it, we can ditch it. That's true.
Because we haven't decided on SysFS yet, because it may be limited by 4K still. I think it's limited.
It's only limited for 4K for text-based attributes. Binary attributes can be bigger.
Not sure about that, but anyway, we'll decide later on that. Other question I have about TSMs. You can have more than one on the system.
We have more than one on the system, but this was kind of more of a not like there's no actual product I know of that's going to have multiple TSM on a system, but it does make the code less. We don't no globals. But the other nice thing is actually I can use it. It's useful for testing, because now I can now you can have one kernel test both the guest and the host side at the same time, just by mocking things up. So it's actually
the same running instance of the kernel testing guest and host.
So testing guest and host, where you have some devices registered to like a host side TSM and other devices registered to a guest side TSM.
And by device you mean sample device.
Sample device, yeah.
Yeah. Okay. So it's now you can have two TSMs. One is for host, one is for guest, and you can test them on the sample device.
Yeah. And I mean, and that but that's basically what I'm using it for, because these things there's so many like different pieces registering things going up and down that it's actually useful to just do a basic.
True. Just gives you wrong idea that you can actually a device can choose TSM. Well, in reality, it won't be able to choose TSM.
The device can choose a TSM. Well, I mean, user space chooses, right? And user space won't have a choice because there'll only be one registered, right?
TSM knows about PCI, and so all PCI devices are handled by this PSP TSM, right?
Right.
And you cannot have another TSM on actual box managing actual device.
Correct. Right. I mean, but like so on a real platform, you'll only ever have TSM 0, and it'll just be like, oh, the TSM 0 is PSP on AMD and TDX device on TDX. And
you know this PSP guy, right? It's a small, now it's RISC-V core sitting on the chip. And if you have dual socket system, and in each socket you have two, what's called CCX, CCD, something. So if you do LSPCI, you see 4 PSPs. There are actually 4 instances of them, but only one is active and master, and you only have to enable this TIO thing in one of them.
I get it.
Still one TSM. But
still one TSM.
I can see a situation when we can possibly have 4 of them, right? And each and one of them will handle only like subset of PCI, only those PCI slots which are connected to this chip, to this side of this chip, right? So the device cannot choose TSM. It will be statically assigned by the motherboard topology. And now we do this TSM thing, and we say you can actually do it incorrectly, and you can try connect device by a wrong TSM.
I mean, but at least in that case, the low-level driver could say, "Oh no, you're trying to connect me to a device I can't control." Right.
Right. Or you can just say, connect this device, and device will figure out what TSM it's going to connect to. But yes, it kind of makes your testing of sample devices harder. That's why I'm asking all these questions, basically.
That's fine. But I mean, but I think
we can do it your way now because it's one TSM and running system, so it's TSM 0 always, and we're good. I thought maybe you have 2 TSMs as well, or plans of having 2 TSMs.
We don't have plans for having 2 TSMs, but I mean, but yeah, that example of a TSM instance per, but I guess would you still have you could even if you had like multiple TSMs and some TSMs do subset of a device, you could still model that as one TSM device and put basically put the routing of it in your driver.
Well, it is one right now. So
is one right now.
And there is no plan of using more than one of those.
Yeah. We don't have that. We don't have that plan currently.
Okay. Cool.
Okay. Yeah. Yeah. But on the virtualization, the BME virtualization. So yeah, so you said we don't have the BME problem. We don't have to enable BME before we lock. That's huge. And the only other thing from that conversation I think is interesting is allowing the device to stay in the run state after you unbind the driver. And that was another comment from Jason that I thought that is growing on me, that once you attest the device, that device is trusted. So why would binding and unbinding a driver change the attestation state of the device? It shouldn't.
Because the reality is most of the devices have driver loaded firmware.
They have driver loaded firmware. So, but are you saying that like the firmware gets unloaded by removing the driver, or does the driver? I thought the kind of firmware would stay resident, like things would stay resident, or actually it's so. But I show my ignorance here, but you tell me.
So I guess it all depends. So I guess inside the VF, that if it's a VF inside the TVM, that's probably not an issue because the driver loaded firmware is on the PF, not the VF.
Right.
Yeah.
But this is like one of the main case worried about is the DDA direct device assignment case, where we need to load firmware before we can do the whole attestation flow.
Yeah.
After you get the attested, firmware loaded, everything up and running, and then you remove the driver, is the question: do we start undoing tedious state at that point?
I guess it would all depend on whether or not there's some sort of function level reset on the device when the driver's unloaded.
Yeah. FLR oh, I guess yeah. PFFLR drops T diff state, right? But
Yeah,
but VFFLR does not.
no, the TDIS spec says VFFLR shouldn't affect anything other than the individual VF. But you just mentioned the direct device assignment case, which is more like a PF than yeah.
Yeah,
So,
if,
I mean,
if it's really worried, then just driver could just do FLR on what you unbind, and that will go to unlocked state and be good.
Yeah. So I don't think we need to solve it. Like if a driver action takes a T diff state into the error state or something like this on the way out or down, I think that's something like the PCI core shouldn't enforce it, but if the driver causes to enter TDI error state on the way out, that's okay. And if people say, hey, I'd like my attestation to not be clobbered by that event, but that's a driver specific fix. That's something, probably not something the PCI core needs to worry about.
I'm having right now discussion internally about config locked state. At what point do we switch to config locked? When we start the guest, pass through a device, so before guest actually sees the device, we do config locked, and then we boot the system, so it's always in config locked, at least from guest point of view. Or we wait till guest decides to attest the device, and at this point we detect this interest, and then we move to config locked state. And the spec suggests then when VMM is finalized the TDI setup, it should move to config locked.
Right.
And what is finalized exactly?
Well, for me, I'm always like the limiting case I'm continue to track because multiple people have asked for it is they say we need to run our driver in shared mode to do firmware loads, other setup, other things before the device gets locked. So like the guest basically the devices arrive in shared mode and can attach to drivers. And then at that point, if you want to take the device into lock state, you unbind the driver.
Well, in this scenario, you say you give TDI to VM in config locked state, then VM will do firmware update or something, which will move TDI to error state. But guest doesn't care at this point because device is still shared and not trusted. And then device driver in the guest will do FLR, right? And VF will come back as config locked again. And then you can just do the attestation and enable VF.
I mean, I don't think we need to prevent a device arriving locked, but the
question is if we insist on VF being in config locked state, like always when you present it to the guest. No. Say you hot plug it and it's already in config locked. But this is what the spec says, and I don't see much point in it.
I don't see much point in it, and it doesn't seem realistic from the perspective of well, devices that can't even enter the lock state because they haven't loaded the firmware. So like some devices can't, and because some devices can't, and because of error handling, and because I don't, the guest needs to be okay with dynamically taking devices from shared to locked or from shared to private. So
okay.
Yeah. Like if people want to follow the spec and only ship locked devices, they can, but that's not going to be. I don't think Linux needs to enforce that.
No, my idea was that I can run a VM with the VF but no IDE setup yet. And just do IDE setup when the first guest asks for, attestation report. So, or even like for run state. Only then enable IDE on the host. I could do that, right?
Yeah, I mean, I think we're also going to need to get we're going to need to get there when we start thinking about like recovery, error recovery. Like if the IDE link goes down, do you want to try to recover? But for me, that kind of advanced feature of guest initiated IDE was.
No, I'm not thinking that far. I'm thinking just make everything boot faster. And if you exclude IDE setup in the very beginning, you will boot faster. And if you do it only on demand, it's later. And what happens later, people don't care that much. But purely boot time optimization.
For
should be still allowed, technically.
I think it will be okay if you just don't set up ID and you just pass through the shared device to the VM, and then you could set up ID before you lock the device.
Sure, it works on my machine. So.
Yeah.
But the spec says it should be in config locked state when you pass through IVF. So, and to have config locked state, you have to have, I don't know, IDE, not IDE. Probably don't need IDE, but our thing will complain if you didn't set up IDE first.
But yeah, I think like, I mean, if we're going to have if we wait, I mean, bind is lock and bind are going to be a signal from the guest. If you get that, if you get that on the host side and the device is not even an IDE yet, I think you could do lazy IDE. I don't see a problem with that. Lazy IDE.
The problem is spec says it's done another way, so that's the problem.
Yeah, I mean, yeah, but like this is what Lena says about spec. There's specs and then there's reality, and especially because of error handling. Like you can't have an error model and then say that the guest can't handle dynamically transitioning this, because that's part of the error model is IDE could go down while the guest is running. So if IDE can go down while the guest is running, then the guest should be able to handle IDE not being set up at the beginning of time. It's the exact same case. Like the spec doesn't say you must shut down the TD if the IDE goes down. So yeah.
Or well, hot unplug this broken TDI, and then hot plug it back.
Yeah, but if IDE goes down, your TDI is going to go into the error state regardless, right? And the only thing that you can do from error is go to unbind. Is unbind
or hot unplug.
Or unplug, yeah. But that's what I'm saying. Like if what you could meet the letter of the spec, Alexei, just by saying I'm just hot plugging devices and not these devices haven't arrived yet. So you're not. But yeah, I don't think anybody's going to be mad that you don't follow the spec at that level. There's nothing.
Oh, but I have one person already. So.
No, well, tell them to come complain on the list, and we can all tell them no.
Okay.
But yeah, I mean, unless somebody can point to a practical security problem, I don't see the problem with it.
I don't know. That's just see, when I told people like a year ago that I can just not enable SDTE, and this will effectively block, well, enable SDTE entry, but not configure it to allow any DMA, and this will block DMA access at IOMMU level. So we have this hardware barrier, and I was told that it's like not everyone has this kind of facility in the hardware. And it wasn't Intel. It was, I don't remember who was that. So maybe there is some platform which relies on config locked being from the very beginning on. I don't know. One of these things. Maybe ARM, maybe RISC-V.
Maybe. Yeah. Like, well, at least Anish has a lock step that's guest initiated. So I think it's not. Maybe it's not ARM. Yeah. I mean, from my perspective, like I think like I was planning for this stuff to arrive shared and live convert, and if people want, but if people want to require it to come required to come locked, I don't think our current design will break that or force it.
Alrighty.
Sorry, I have a little visitor in the office. But yeah. So I'll send out V5, and then we can look at the guest side. But I think we're making progress. But I'll rip out unless the Yulun. Do you have any? Do you have a use for the attribute groups that the TSM that can register to TSM register time? I'll look at the ARM patches. I'll see if he uses them. And if nobody's using them, then we can I'll drop them.
For now, I don't have some TSM generic groups.
Okay.
Yeah. No, I don't have.
I was wondering if we have some more time. I have this issue with the IOMMU. So when we boot the machine with the pass-through device, VFIO will pin and map all guest memory, right?
Yeah,
so
yeah.
Now in IOMMU, AMD, and say we use huge pages. Or, well, IOMMU will always try using its own idea of huge pages. If it finds a bunch of consecutive pages, say 8 meg or 256 meg of contiguous pages, it will map them as a single page. So we do this, and it works fine for non-confidential VMs because memory is pinned, nothing is moving, and it's all good. When we go to confidential computing, we have this RMP table thing, which is used to allow or disallow access to specific guest memory. And that thing operates at 4K and 2 meg granularity. Okay, we can limit to 2 meg and 4K. Now, when we start the guest and we say use 2 meg huge pages to back the guest memory, right? So IOMMU maps with 2 meg. Guest nested page table is using 2 meg mappings. Well, good. But if we make at least one page shared in the guest in runtime, right?
Okay, you mean the conversion of 4K page inside the large pages?
Yes.
Okay.
In NPT, it will remain 2 meg. Well, it doesn't really matter what it is in NPT. It matters that in RMP table, 2 meg page will be smashed into 4K pages.
Yeah.
But IOMMU will be still using 2 meg. IO PTE, IO PDE, PTE, right? So I need to smash that. When
you need to smash the LMMA page table mapping as well.
Right.
Okay.
But at this point, I don't have device in trusted mode, so I don't care until I move it to run state. And when I move to run state, I need to synchronize IOMMU page table with RMP table. Or in your case would be what? Nested page table? Some synchronization needs to be done, right? Or you allow IOMMU pages to stay huge?
For Intel, I think for Intel and ARM, currently we don't have this problem because we share the L page table with the KVM EPT. So for now, we don't have this problem because the IOMMU for Intel and ARM doesn't actually handle the IOMMU mapping because doesn't handle the private mapping. Yeah.
So for every page state change in your firmware, you update all IOMMU pages as well.
Yes. Yes. The host doesn't actually care about the MMU page mapping because it follows the KVM MMU mapping. But I know that for MD, you have separate page table, same as the legacy LPT, and you need to smash the memory mapping. Yeah.
Okay.
Yeah, but I think maybe you can just follow the guest MMFD's notification. If the guest MMFD says that we need to convert some pages and we need to smash the large private pages, and the RMME for MD follows. Is that possible?
For that kind of stuff, we have things. If it happens when device is in trusted mode and we need to make one page shared, we have hardware facility to do this atomically. Yeah. Update RMP table and IOMMU table. But that's like the switching from untrusted to trusted is what I was worried about. I have a hack in QEMU to do just that. I was wondering if it's just me who is having this problem. Sounds like it's just me.
But I think if you have a shared pass-through device in guest, then the RMMU page table for the shared device should only map the shared part of the memory, is it? You cannot actually map the whole guest memory.
Well, I can. If it's not allowed, then IOMMU will check RMP and barf.
Okay.
And when I get via IOMMU, then I will definitely want host IOMMU page table to map everything, because guest nested IOMMU page table will handle permission per page.
Yes. So my understanding is that if we forgot about private devices and we just talk about shared pass-through devices, for now, our implementation for shared devices is that the shared devices only maps the shared part of the memory. We don't map the private parts.
Right. Now I map everything. Because we have in-place memory conversion.
Yeah, I think it makes sense that the shared device only maps the shared part. And if you do that, I don't think when you convert it to private, there would be some extra effort for you to reorganize the menu page table.
Sure. Well, remember, was there any progress on DMA buff kind of exporting of VFIO MMIO resources to QEMU?
No, I see that Leon is sending another DMA buff patch set based on the two-step DMA APIs, and I think that is the progress. That is a progress on the DMA buff side, but we still need some new APIs to expose to implement the importer mapping things. That's not happening today.
I didn't really get the last part. Import mapping things?
Yeah, import mapping things, it means that the DMA buff, the DMA buff provides the physical resources to importers and lets the importers do the mapping on itself. So that's not in that's not implemented today. We don't have progress on that yet.
Is it because Helvig is opposing something, or we have agreement that DMA buff needs to be changed and just haven't changed it yet?
To have the important mapping, DMA buff should have some API changes, I think, and we for now we didn't. I didn't implement some more patches on that. I had first version, and it just like raised some requirement. Yeah, and for now, I think importer mapping, the importer mapping ideas is still alive, but we didn't progress on that yet.
Yeah, I think we're taking a version to get the link ID set up, all that stuff kind of settled, and then we'll circle back to start fighting on the DMA buff again. So it's just on pause.
Yeah, but the good thing is that
you have like multiple people doing this and that, and
yeah. But the good thing is that the two-step DMA things is implementing on the DMA buffer side. That's the base of the importer mapping things, because the DMA buff itself is implementing some allows the users to use the physical resources now, and it means that we are actually allow the DMA map the DMA users to touch the to see the physical resources.
Oof.
Yeah.
Okay. Sounds like it hasn't settled yet.
Yeah, it's not settled yet.
Okay. Any other topics for today? I think that's all I had.
No, not on my side.
Okay. Cool. Sounds good. Yeah. So yeah, watch for the next posting there, and yeah, we'll keep going. And
okay.
Alrighty.
Yep. Thanks for joining.
Talk to you later.
Yep. Talk to you guys later. See ya.
See you. Bye.